Okay, I'm going to go ahead and record a session here on getting started with regular expressions in Marcedit. First things first, I apologize. This was the session that I had planned to do live stream. I tried to work on it on the YouTube live stream. I have a feeling the problem I was running into is I probably need multiple devices if I'm going to try and stream as well as present at the same time. I was just running into all kinds of trouble with the bit rate. So I decided rather than torture everybody for an hour, I will go ahead and just record the session as a static session and post it. And if there are any questions, folks can toss them out to the list. The idea behind this session was to provide basically a basic introduction to regular expressions in Marcedit, to kind of introduce you to the particular resources that are available, talk about where they can be used in the application, but also some strategies on how they can be used. Hopefully that'll be worthwhile to folks. Again, I wish that this was live because I was hoping to get questions, and in fact I kind of counted on having questions so that I could update them as I go. But we'll go ahead and struggle through this, and hopefully it'll be useful for folks. All right, so the particular topics that I want to cover very quickly, I want to talk about generally Marcedit's regular expression support, so what's it based off of, and if you have regular expression background, what's going to be useful. I'm going to talk about understanding .NET's regular expressions. We'll look at the documentation that Microsoft provides, and then I'm going to tell you what you actually need to know in terms of what are the parts of the regular expression language that are primarily useful when working with Marcdata. Next, I'm going to look at how Marcedit implements regular expressions. We'll look at some strategies for going through them. We'll look at a couple of examples, simple examples, that just kind of walk through a couple of generic topics. And then we'll probably look at a couple regular expressions that make use of some of the extension functions that Marcedit provides for regular expressions within the application. I point out the extension functions partly because this is an opportunity to demonstrate that the regular expression language doesn't have to be static. So while .NET has a particular expression language that supports a very specific function set, I've added in Marcedit the ability to enhance that function set. So we'll see in the examples places where you can use functions to turn all of the characters in a captured group either lower or uppercase. Potentially, that means that within the application, if there were components of the expression language that were missing, which was part of the reason for doing the lower and the uppercase, because in some regular expression languages this is really easy to do. But for example, if there are some components of the expression language that are missing, or where enhancements would make sense within a mark processing environment, we could potentially think about how those might be implemented. So what I'm thinking particularly is a question that came up on the list this week where someone was interested in how you could do mathematical functions on data captured as part of a regular expression. Since a regular expression only processes text language, there's no such thing, as far as I know of, in any of the regular expression languages available. But that doesn't mean that you couldn't build into the language, kind of like I've done with some of the extension functions, the ability to be able to perform mathematical functions on particular captured groups within an expression. Not quite sure we'd want to go there and do that, but it's an option. So those are the kind of things that I'm not going to expect folks to answer now. But by exposing you to some of the ways that the application has extended regular expression support, the .NET regular expression engine and support, hopefully that'll, if that sparks ideas, we'll let you know that that's potentially possible. All right, so let's take a look at this. So Marcedit's regular expression support. Originally, when the application was designed, regular expressions were a little bit of an afterthought, and in fact, originally when they were there, I wrote the expression engine myself, which meant that it was woefully inadequate and only targeted a handful of fields. Today, the regular expression support shows up just about anywhere where you have an edit function and a text box. So in all the global editing tools, delete, edit, copy, swap, build new fields, extract, delete, selected records, validation processing, linked data tooling, a lot more things within the application. All of these can use regular expressions in order to process the data or to select data or validate data. And in most cases, especially when it comes time to do data processing, I've included cues, visual cues in the interface to let you know when you're turning regular expressions on and off. This is actually, you would think that that would be a given, but for those of you who use Marcedit for a very long time, you'll know that that hasn't always been the case, that turning regular expressions on in some functions was a process of knowing what the characters, special character sequences were to turn it on. I've tried to do away with as much of that as possible, so that way the user experience is much easier, and it's a lot, it doesn't require quite so much digging through blog posts or the listserv to try and find these special combinations of characters, rather than doing that, making sure it's all available up front. So a little bit more about the expression engine. Marcedit's regular expression engine does use Microsoft's.NET. This is because the application is written in C#, and I should say it's not Microsoft's .NET, it's actually .NET based on the ISO standard, the standard that was accepted, and I forget what the number is, but it's a Microsoft submitted C# to the standards board. There's an extended version of the .NET language that is primarily controlled by Microsoft, and then there's a core set that's in theory more open. And the core set is implemented the same way across all platforms. So Marcedit natively works on Linux and Windows and Mac, and the core components that are used across all of those systems will work the same. So while the documentation I point you to is Microsoft's documentation on their website, the documentation there will work for any of the various operating systems that you might be running Marcedit under. So a couple of things about it. So regular expression processing will work primarily on one field at a time. The application does this to protect you so that you don't delete a lot of data. You can override that processing instruction and process data across an entire record, and I'll show you an example of that. But it does by default deal with field by field at a time. The expression syntax is fairly Perl-like. I have a feeling when Microsoft developed the regular expression engine in .NET, they borrowed heavily from things like Smalltalk and Ruby, and I have a feeling that Perl's expression engine was one of the things that they looked at closely when they were building it. So this is the kind of base layer. All right, so Microsoft's regular expression language. So the regular expression language is broken into a lot of different parts. So you have these character escapes, anchors, character classes, groupings, qualifiers, and substitutions. Let me get my mouse here and open this up. All right, so this is a link to the documentation that will take you to Microsoft's current web page for their regular expression quick reference. You can see here that they break it down into the particular classes. The ones that you're most interested in are character escapes, classes, anchors, groupings, qualifiers, back references, and substitutions. You will see looking through this list that there is a significant number of elements that are defined here. So for character escapes, these are things that tend to be unprintable characters, so things like new lines, vertical tabs, realistically, most of the things that show up in a MARC record, they're characters that print, except for things like new lines. There are going to be times where you may be looking for a new line or a carriage return, in which case you're going to have to use one of these escapes. The other place escapes tend to end up being used is when looking for hexadecimal representations. So you have an escape here in the hexadecimal notation, as well as Unicode data. So Unicode data is not well represented within the regular expression engine, and this is fairly universal. Depending on how the regular expression engine treats streams of data as they're being read, a lot of times Unicode data gets broken down into component parts, and so searching for a particular Unicode character won't work. Now, one of the things Marcedit does try and do is in the .NET language they have these this notion of being culturally invariant. What that essentially means is that there is a set of functions that are primarily designed for working with Latin-based content, and there are a set of functions that will expand the character set and will attempt to resolve a particular set of characters as not just Latin, but in other languages. The tool tries to use that character invariant processing whenever it's applicable. Sometimes it's not, and in those cases you may find trying to search for a Unicode character results in no results, in which case you need to search for the character using its Unicode representation, the number, the hexadecimal number. It's a 4-digit number, but generally that's not something that you have to worry about. The other one is just the backslash. The backslash is a representation of a value that means that you are escaping the next value that follows it. So the values up on top here, when you see these character escapes, represent characters that generally aren't printable, but this backslash is also used when you run into special characters. So let's say I need to reference a $sign. A $sign has special meaning within the .NET regular expression language. In fact, it has multiple meanings depending on whether you're finding or replacing data in a string. If I need to represent a literal $sign, so I actually want to print a $sign, I have to escape it, because if I don't, when I'm searching for something, it means that $sign stands in for an anchor, meaning end of line. If I'm doing a replacement, that $sign stands in for a grouping number. So that front slash, that forward slash, then becomes a value that's important, because anytime you run across a character within the regular expression language that has special meaning, like a period or an asterisk or a bracket or a parentheses, if I'm looking for the literal value, the actual character, I need to remember in my regular expression to escape it, and this would be how I would escape it. If I want to actually look for this character, I have to remember to escape it, which would mean putting in 2 of these slash marks. All right, we have character classes. Character classes are how we group content together. A lot of times they are used to look for ranges of content. So A to Z, small a to big Z, 0 to 9. That's what these character classes end up being used for. They're matching groups or ranges of characters, and they tend to be, as you can see here, case sensitive. So if you're looking for all uppercase characters, you can actually set up a range that says I only want to match values that are capital A to capital Z, and I'm going to do one of those. You can also do negative matches, and you're going to see this in a couple of my examples, where sometimes what you're looking for is the lack of a character. So a good example of that would be looking for any fields that don't end in punctuation. I'm going to be looking for characters that lack punctuation characters, and so I'm going to use this negative matching, does not match character. So I'm going to be looking for that. And that's where I'm going to use these. So these are characters that represent, they stand in for things. You can write these out inside those parentheses, inside those bracket bracket inside that bracket syntax. But let's say I want to match any word character. Well, I have a notion here, which is a / and a W, lowercase w. And rather than having to figure out what are all of the word characters in whatever language I'm working in, I can use that /W to represent all of the characters that might potentially be word characters within my various languages that I'm working with. Likewise, if I use a capital W and a / I can match any non-word characters. And so in the example that we'll look at, where we're going to be looking for fields that are missing a punctuation mark at the end, rather than trying to figure out what are all the potential punctuation characters that may or may not show up at the end of a field, we can use this /W, capital W, within a bracket using a negative marker to look for data that's missing a non-word character at the end of a field. And so that'll be one of the examples that I show you. Likewise, you're going to see I use these all the time. I like using digits, sometimes looking for matching decimal digit characters. So I want to find something that has so many digits. So great for if I'm looking for a date. I want to match dates that are actually numbers and not dates that maybe have question marks at the end of them. All right, anchors. Anchors tell you a little bit about where you are in the line. So that little caret, when used outside of a bracket, stands in for the start of a string. So it's the beginning. So I'm matching from the beginning of a line. The $, remember, I mentioned it has many functions. In this case, it means the end of a line. So it's before you run into a new line character. And just as a caveat, you'll never see new line characters when doing matching within Marcedit unless you've specifically told Marcedit in the replace function that you want to do a multi-line match. Otherwise, Marcedit reads the field data between the equal sign and the beginning of and at the end of the field before the new line occurs. That way you don't have to deal with processing line data. Hopefully that makes things easier. Grouping constructs. So I'm going to show you some examples of grouping, but grouping is one of those things in regular expressions that you're always going to be doing. And in fact, when people ask me about how I work through regular expressions, I try to explain it in a way almost like, and I'm going to show this to you in a second, like I would diagram a sentence. A regular expression, when I'm working with a set of marked data, isn't so much about trying to figure out how I'm going to find the piece of data that I'm going to edit or replace or modify. For me, it's actually about trying to figure out how I take the field and break it down into logical blocks so that the piece of information that I'm interested in is just found in one of those blocks. And sometimes that means having a lot of blocks, a lot of sub-expressions that create groups within the fields. Sometimes it means having one. But what that means is it means I can sit down and kind of create a strategy for how I'm going to understand how the application is going to see the field. Because in a sense, that's what I'm doing. I'm trying to determine with my field that I'm breaking up, for lack of a better term, what's the subject, what's the verb, what's the noun. And if I was to continue with this kind of idea of a sentence diagram, to some degree, I'm looking at it. I'm saying that these are component parts of this mark field, and the component part that I really want to edit happens to be this one. This particular one that's in the middle. Sometimes we have to name those parts. So in the .NET regular expression language, by default, when doing a replacement, these groups are referenced using a group number. So let me pull up a notepad here. All right, so in a field example, let's say 500 // $A test $B test1. So let's say we have a field like this. Let me make it a little bit bigger so that it's a little easier to read here. Okay, so let's say a field example like this. Let's say we were trying to break these up, and we wanted to capture data before the subfield A and before the subfield B. So in essence, we want to have three categories. We want to have a category here, and we want to have a category here, and we want to have a category here. All right, so the first thing we do is we figure out our sentence structure, so our field structure. So when we finish, we would like to have a group 1 equals 500 // we want a group 2 that equals $a test, and we want a group 3 that equals $b test 1. So when I look at the regular expression language, we can see that we use these grouping constructs. This is how I'm going to create a sub-expression that's going to find the individual data that I'm querying. Get my text box back here. There we go. All right, so that's how I'm going to do it. So I'm going to create some sub-expressions. So the first one I'm going to use is I'm going to find the expression that's going to search for that 500. So I create my group, and I'm going to say equals 500, and I'm going to take the next 4 characters. And so what does that tell me? That says I'm looking for a field that starts with equal 500. That period means any character, and I'm going to look for 4 of them. So if you look at this grouping, I haven't gotten down to it yet, or these qualifiers here, you can see that I can create a qualifier that matches. In this case, the asterisk means 0 or more times, a plus sign 1 or more, question mark 0 or 1. But this syntax here that uses parentheses, or the little squiggly parentheses, allows me to say that I want to match exactly this many times. And so that's what I've done here in the example. I've said that I know that my field starts with an equal 500, and I know because of the way that Marcedit structures its data that there's going to be 2 spaces and then indicator values. And so I'm just going to match the next 4 characters, which should be those 2 spaces and then the 2 indicator values. So the next thing I'm going to do is I'm going to match my next group. So my next group is going to create a new sub-expression. I'm going to look for subfield A, and then I'm going to match any character that doesn't equal a $. So what does that say here? So you can see I used a / and a $sign to say that I'm actually looking for a real $sign A. So that's going to match this first section here. And then I told it I want to, in brackets, in a range, that I want to match any character that doesn't equal a $sign. So I'm going to take all of these. And you're going to notice something. There's no / in front of the $sign character here. It doesn't have to. Inside the brackets, the .NET Framework doesn't require you to escape the $sign. The only data elements inside the brackets that need to be escaped are this caret, if I actually want to use a caret that I'm looking for, the brackets, if I'm searching for actual bracket characters, and the /. That's pretty much it. So inside of the brackets, I don't have to escape the value. I can. If I would have put a $$ it would have looked for just a $sign, but I don't have to. And then the next value is going to be I'm going to take everything, because I know there's only one subfield at the end. So I'm going to go ahead and take everything after that. So now I've created 3 groups. And so what I mean by 3 groups. So if I was to output this data in a replace function, Microsoft and regular expression languages treats each one of these sub-expressions, each one of these, as a number. So this is number 1, this is number 2, and this is number 3. So number 1 equals 500 / $2 equals $A test, $3 equals $B test 1, and then there's a 4th value that not many people use, which is $0, which matches the entire string, which would be equal 500 / $A test, $B test 1. Now I have another option. We noticed up on top here when we were looking at sub-expressions that there is this syntax here where you can name a sub-expression. See this $ name or question mark name. This is actually kind of a quirky syntax. I'm not familiar with it in any other languages, or at least not ones that I use often. And so why would you want to do that? Well, where this comes into play is in cases where when I'm doing a replacement, I end up having a value like this, that $1, and then a numeric that follows behind it. If, for example, I was going to write out, let's say I wanted to take this value here, and what I was going to do is I was going to turn it into this, equals 500 / $A test1, $B test1. I was going to add a 1 to the test, or let's even say I'm going to add a 12. That creates a problem because when I write out the information to print the data that I've captured back out, I would print it out as $1, $2, 12, $3. And I think you can see what the problem is. When the regular expression reads this, it reads this value as 212, not 2 with a 12. And so the way that .NET gets around that is it allows you to name groups. So in this case, let's use our example up above here again. We have our group here that's 500. I would name this group because this is the group that's going to be problematic. And so what I do is I use a question mark, a little alligator sign, and the group name, and then I close my alligator sign. And now it has a name. So when I reference it, I'm going to call it by that name. Now this has an impact on the rest of the group numbers. You would think that you would be able to continue to reference them in the same order, but you can't. So this will still be $1, but this one will now be referenced as 1, and this one will be referenced as 2, and then $0 will still match the entire string. So when I output this back using a replacement function, the value would look like $1. The value of the named group, 12, $2, and that would output, when run, it would output this value. So it's kind of quirky in that way, especially if you're used to using regular expressions. This is a somewhat different syntax in the sub-expression language. These are the qualifiers. I mentioned those already. Back references, this is where you can actually reference a previously matched value. This is really useful if you're doing matches that are redundant. You can match a value and then use that value to continue to match forward using a back reference. I won't have any examples of that because that's kind of different. You can use OR statements. That's an OR statement. You will see functions that show up on the list that include OR statements. You can also use negative matches. So in these cases, you can use yes-no matches. So things, you can create assertions within the regular expression language that allows you to do expressions that only run if a negative assertion is processed, which is interesting and useful in very specific ways. So for example, if you had a regular expression where you were actually looking for, you actually wanted to look for fields that did not have a specific word in them. That is a relatively complicated expression because regular expressions by default are looking for groups of words, groups of characters. If I want to actually look for a word, I have to create a negative assertion that actually looks for a word and evaluates as either yes or no. And then substitutions, we already looked at these, how substitutions reference those groups, these sub-expressions, and they output in their group number, or if they're named as their named group. This is important because you're going to need this, especially in one of the examples. Again, $ signs are represented in lots of different ways. If I actually want to create a $sign in the replacement part of my regular expression, I have to use two $signs, because that's how you print out an actual literal $sign. It's not a / $sign anymore. That's only used in the search part of a regular expression. In the replacement part of a regular expression, a literal $sign is represented as two $signs. All right. Excuse me. So that's a lot of stuff. Lots of parts of the regular expression language. Fortunately, Microsoft has provided a better reference. There are PDF representations. I'm going to quickly open this one. And what you're going to see is they've taken out a lot of the information that's in the documentation and provided you with a quick sheet of information about the various regular expression elements that you have available to you. This is actually really handy. I can simplify this even further. When you use regular expressions in Marcedit, the most important parts of it are the values that you're seeing here. In the character escapes, they're primarily going to be things looking for digits, new lines or carriage returns. If you do multi-line searches, that literal $sign character, and then hexadecimal or Unicode representations, as well as values that are looking for, I guess, an escaped / and I didn't add that to the list. I should have. Excuse me. But those are the primary character escapes that you're going to run into during the course of working in the application. Character classes, there was a number of different ways that you can do character classes, but the ones that you're going to see on the list almost universally are just these two values, ones that are looking for a range of or group of characters, or one that's looking for a range of or group of characters that don't show up in a string. Likewise, for the grouping elements, there are lots of grouping elements in the .NET expression language. Really, we really mostly care about just the vanilla sub-expressions, two open parentheses that has that regular expression sub-expression inside of it. Anchors, we're pretty much just looking for beginning and ending of lines. Qualifiers, the ones that you'll see most often that I write, will either have a asterisk for any characters, 0 to many matches, a question mark, 0 to 1, a plus, which means 1 to many, or this squiggly parenthesis pound sign, which is a specific number of matches on a particular character set. And then the last one are substitutions, where you're going to see either a $sign or a $sign number. So the grouping element, the group number for the sub-expression. As we've seen in the just early examples, obviously there are other ways to do those substitutions. There are going to be times where you have to name them. But like I said, those are few and far between. And in fact, the place where you're primarily going to have to use name substitutions is when you're doing something like doing indicator value updates, because those are the times when most likely you're going to run across data that needs to be represented as numerics, or potentially I could see application for that if we ever were to include some kind of mathematical functions in a regular expression language, since the data being output would be numeric potentially. All right. So how do you understand regular expressions? So like I said, part of the challenge of working with regular expressions within any application, but particularly within Marcedit and Markdata and all the ways that we look to edit the information, is trying to figure out two things. One, within Marcedit, different functions see different levels of field data. So for example, when I'm working with the Edit Subfield tool, I only see subfield data. When I'm working with a different editing tool, I will see different levels of that field data. So part of what I need to do when I think about using a regular expression is figuring out which of the global editing functions makes the most sense. Can I target a specific part of a field, in which case maybe it doesn't make the most sense to use something like the replace function, which gives you access to the entire set of field data? Or do I actually need that granularity? Do I need to be able to have access to the entire field, or maybe even all of the fields within my record? The last thing I need to think about is what's my strategy. So again, I think about regular expression processing as almost like sentence diagramming. So how do I, when I start thinking about how I'm going to go about editing a string, or the potential variations of the string and how it's represented, I'm thinking about how I diagram that, and what the strategy would be to make sure that I can isolate the part that's going to be the ephemeral part, the part that's going to be the difficult part, that's probably shows up in lots of different forms, away from all of the rest of the data in my field that I really don't want to touch, that I think, even though may be different in every case, probably has some specific characteristics that allow me to create that kind of diagram. So like I said, you need to be able to figure out where in the application you're going to, what function you're going to use in the application. So I have a couple of examples here just to underscore that. So the replace function. The replace function is probably the most powerful in terms of the regular expressions, because not only does it keep track of, as you see here in these drop-down boxes, the last expressions that have been run, but it includes an option to do multi-line evaluation, which allows you to search the entire record, and not just search the entire record, but search for characteristics in multiple fields, as well as capture data in multiple fields and move that data around within a record. So you can do very, very complicated work within a record set, within a file, a field, multiple fields. But you have to be very, very careful, because you have to make sure that any data that you're capturing, you're putting back. Otherwise, it's really easy to delete large sets of records. The other option you have here is this perform, find, and replace if within the regular expression function, to attempt to minimize the amount of times you have to do multi-line evaluation. It allows you to do conditional replacements. So you can actually run a find, which can be a regular expression, against a record set, to determine if a field or values have a particular, meet a particular criteria. And then based on that criteria, it then allows you then to search again and do a find and replace against a particular set of text within the string. So the replace function is very powerful in that it opens up a wide range of elements, data, and options to you while using regular expressions. And this is an example here of what I just said. And you can see here I've highlighted the data that you would see. You could see if you were using a replace function. And in reality, I could actually highlight the entire record if I was using a multi-line replacement. So the add and delete function, this is another tool. The delete function gives you access to regular expressions. And the delete function works almost like the replace function in the sense that the data available to you is the entire field, from the equal sign to right before the new line character. And the reason why the regular expressions makes that available to you is twofold. One, if you're going to do indicator data processing, you need to be able to have all the data from the equal sign and forward. And two, sometimes you may want to do processing against a group of fields. So for example, let's say I wanted to process all of the subject fields, but inside those subject fields I wanted to be able to target very specific fields. So I could, using a regular expression, set my field value to 6xx. So I'm going to evaluate all the 600 fields, and then within my regular expression target the 650, the 651, and maybe say like a 655 or 610, and target just those specific fields using a regular expression, and be able to do it in one pass. And maybe I'll show you an example of how that might work. So again, this is the data made available to you, this entire line, through the delete function. The edit field function works slightly differently. The edit field function is a convenience function that allows you to essentially work with data just in the field. And what that means is, if you look at the edit field function, it gives you access to the data prior to or after the indicator. So in the edit field function, all of the data here in the equal 100 indicator 1 blank indicator is unseen by the regular expression engine. The regular expression engine only sees the data between the dollar signs, or in the case of control values, the data after the two spaces. And finally, the subfield edit tool. Subfield edit tool targets just a subfield that's been defined. So in this case, if we take looking at the same record, if I was going to target a specific subfield, it would just show me the data within that specific subfield. And it's important to note that in Marcedit, subfield data is all of the data between the subfield marker to the next subfield marker. So in this case, you'll see there's a punctuation. It's hard to see, you'll trust me. There's a comma at the end of this name, and then before the subfield D. That comma is treated as part of the subfield A. So there are times where punctuation, particularly if you have a subfield B or a subfield C, that punctuation that comes before those subfields wouldn't traditionally be thought of as part of the subfield that preceded it. But within Marcedit's edit subfield tool, that entire set of data, the subfield and that punctuation that follows it, is treated as part of the individually defined subfield marker. All right, so let's think about how we do regular expression basics. So, like I said, I like to think of regular expressions like a sentence diagram. And for those of you who aren't big fans of sentence diagramming, I'm sure that this probably brings back bad memories from when you're in school. I know it does for me, even though I'm an English major, but I was an English major. When I think about regular expressions, essentially this is how I'm breaking them down. I have an example here. So I'm going to break down an expression looking for how I create groups around it. So in this case, if I had a regular expression wherein I have these two fields, two 500 fields, one without a punctuation mark and one with a punctuation mark, I'm going to ask myself, what are the pieces of information that's most important, and what are the values that I'm interested in querying? And in this case, the values that I'm interested in querying are everything here up to the last character. And that last character could be either, in this case, for these two fields, the last character is either going to be that in or that question mark. And I'm interested in finding ones that have data that don't have punctuation at the end. And so in my structure, I have the entire field, and then I have this block which stands in for that mythical last character, that last character that's not a word value. And so the expression is one that looks like this, where I have a single group looking for the 500 field, matching any character, and then the last character here, so the last value in the sentence, is looking at the last element to see if it's a non-word character. And I know that I'm looking at the last character because I include an anchor at the end that tells me that it precedes the end of the line. So here's some examples. So we're going to look at 3 examples. One does look at this adding a period to the end of a 500. One will move some data between fields, and one will break up 2 fields. So these are simple examples. And so let me go ahead and open Marcedit. All right. All right, so let's look at the first one, and I'm going to go ahead and increase the font size a little bit to make this a little easier to read on the screen. Okay, So the first example is going to be looking for that that set of data that doesn't have a period in it, and this comes up quite often on the list. So here we have 500 fields. We have a variety of punctuation marks. We have a period. We have a period here. We have question marks. We have open values here, and then we have one here that doesn't have a value on it. So we want to go ahead and just modify this one 500 field that's missing a punctuation mark. So this is one of those where we could actually look at two different ways of doing it. We could either use the replace function, or we could use the edit field function, depending on which you are interested in. Let's look at both. We'll start with the replace function. So replace function, I would look at how I'm going to create the groups. I want all the data up to the last character, so I'm going to say equals 500, taking all the data, and I'm going to look for things that do not match word characters, and at the end, so that's my expression here, equals 500, any character, and then my brackets tell me I'm looking for things that do not match a word character. And then I'm going to go ahead and say that if I find one, I want to say $1 and put a period there, and I'm going to use a regular expression. And when I run that replacement, I see that I get one modification. And if I look at that modification, I will see that it's added a period here without adding periods to any of the other elements that are there. Go ahead and undo that. All right, so let's put it back. So now we have that period. So we can also use the edit function. So the edit field function basically takes one part of the process away. I'm not looking for, I don't have to add that 500 group because I can target the 500 field. And then what I'm going to do is I'm going to create a group that says dot anything and then does not equal word character, end of line. And then I'm just going to do $1 on period again and use regular expressions and process. And again, this isn't any simpler, honestly, than using the replace function, but it starts you off by being able to target it differently. But when I look at the replace function, we see again that just this particular field was picked up and the values were ignored everywhere else within the application. All right, so I went ahead and wrote this out for you so you can see it with an explanation of what's been done. All right, let's look at the second one. So the second one we have here, we're going to add a value in between some characters. If we look at our record here, oops, lost it, sorry. All right, so if we look at our record set here, we can see that here in the 245, we have here a subfield A, a subfield C, and let's say just for the sake of laughs, we want to put a subfield H in between here, even though we would never do that anymore because we don't want to. Let's say we were going to, just as an example. So in this case, again, we could use either the replace function or we could use the edit subfield function. And essentially what we're going to do is we're going to try and create groups. We can either create, we could create multiple groups. We could create a group here that has the 245 and then everything in this field and then everything in this field, which probably would be one way to go. Since I know I'm not going to be working with any of this data, I would probably create a group that goes to here. That way I could avoid having to have it in two groups. Although that does complicate things a little bit, because what that means is that this value here, here is a little more difficult to match. So let's go ahead and just break it into three groups. So we'll start with our field, so 245. And we don't care about any of those characters there. We're going to capture everything, any indicators regardless. Then we capture the subfield A. And what we're going to do with the subfield A now is we're going to do two things with it. We're going to capture data until we get to until we don't get to a subfield, and then we're going to take what's left here. And we're going to see this because you're going to look at it and it's going to not look quite right. And so then we'll do it again. So then we're going to replace it, $1, $2, $H, cartographic resource, $3. And we check regular expressions and we run it. And we see the modification here, and I'm not going to get rid of that. We look at our modification here that happened, and we see that it did capture the 245, it did do this, it did put in our subfield H, but it put it in before this, that slash, because again, remember when I told you the way that regular expressions work, in this case what I did in this expression here is I tried to create a group that stopped here when it got to a field that didn't have a dollar sign. So that's problematic. I can actually adjust this. I need to know a little bit about my data, but rather than using that syntax of match everything until I get to a dollar sign, I can use match everything and then change the start value on the other side to represent the data that I want to capture. And so in this case, I can change it so that I'm actually looking for the punctuation and then the dollar sign that follows it. And if I undo this and run it again, we should see that the data gets inserted here before the punctuation mark, because we use the punctuation mark and the dollar sign here, the subfield code, as our anchor points in terms of determining where our sentence, our field fragment gets broken up. All right, the last one we'll do, my field back here. All right, the last one we'll look at is actually breaking data up. Occasionally this happens where you have a field that needs to be turned into two fields. So here I have this. There are a couple different ways to do this. You can use the swap field function. You potentially may be able to use the build, the swap field function would probably be the easiest way to do it if you were going to not use a regular expression. But I can use a regular expression. It's actually fairly straightforward in this case. In this case, I know that I want to do two things. I'm going to actually capture this value because I want to reuse it when I create my new field, and then I want to capture the data between the subfields, so subfield and between the subfield. So I will go ahead and do that. I will go equals 856 and take those 4 characters, and then I'm going to look for the subfield character, and I'm going to match everything that does not equal a dollar sign, and then I'm going to match all the values behind it. That should take the subfield U and then create another group for a subfield U, and now I just output the data so that it shows up in the order that I want. So I put back the field, so $1 and then $2 for the data that follows. A new line, so /n represents a new line in regular expressions, and then I'm going to put $1 back, which is going to reprint the 856 again, and then $3, which will print the second subfield U. And when I check use regular expressions and replace all and look at the values that have been created, we see that the data has been split up appropriately and reusing the values here without having to rewrite the field indicator combination that I was using before, which is kind of handy. All right, so I had mentioned that one of the things that the regular expression engine in the .NET language doesn't have is it doesn't have easy ways to do lowercase and uppercase. And so one of the things that I've tried to do on occasion is extend the language. And so we have these two functions, L-case and U-case, which allows you to turn things lower and uppercase. These can be applied to either data in a string literal, so you can actually use the syntax that looks like a text box here. You can use this using syntax like this, L case my data, and the tool will turn my data into lowercase L case $1, which will turn all of the data that's represented by the sub-expression $1 into lowercase, or U case $1, which will turn everything inside the group represented by $1 into an uppercase value. So if we apply that here, we see that we have a value here that's in all uppercase, and we want to go ahead and turn that into a lowercase where we have the R stay in uppercase and the rest of it turned to lowercase. Now there's some problems with this. Marcedit does have a tool. If you go here to edit shortcuts, there's a case statement. I can tell it to do title case and say 500 and tell it to go ahead and do that. And whoops, I forgot to add the subfield A. Sorry. We'll do initial case. 500 subfield A, and we run it. Yes, and if we look at it, we see that it did fix it here, but it also changed these ones here, and that is not what we want to have done, because the tools that Marcedit has doesn't have any idea or any way to know what are proper nouns. And so in these cases are proper nouns, and we don't want to update these. We really want to just target this value. So this is where regular expression comes in handy, because we can look for fields that are all uppercase. So let's go ahead and do that. So we're going to go ahead and look in the 500 field equals 500. We're going to take 4 characters to represent the indicators, and then we're going to look for the subfield A. And then what we're going to do is we're going to take the first value, because we want the first value is going to stay uppercase. So we use $sign as the subfield A. We're looking for anything that's A to Z, and then we follow that up with a value that's going to look for elements that are in uppercase. And so what we're going to do is we're going to say A through Z, and we also want to pick up things that are word characters. So we're going to use something like, because we want to be able to pick up any field that has spaces in it and blah blah blah. Probably something that looks like /W, which should get us any non-word characters too. So anything that's uppercase and then a non-word character should match that value, and we're going to find out here in a second. So when I replace it, I'm going to put my $1, which will put the 500 field back, my $2, which will add the subfield A and the first character that we want to keep uppercase, and then we use L case and $3, which will tell the application that it wants to turn everything after that lowercase. Check regular expressions, and we run the replacement, and we get 14 changes, which sounds like a lot and is a little bit crazy, but if we look at the process here, we see that only this value was changed. The rest of them are stayed the same. So what does that 14 mean? 14 actually stands for all of the characters in this line, because each one represents a replacement. This is something that is a piece of functionality that's on my list to update, which is to change in cases where you get values like that, which you would probably, I think most people would probably expect to get 1 back on that replacement rather than actual number of characters changed. I'm thinking about expanding the way that this works to giving you a number of fields updated and then number of changes made. Because the 14 actually is a true representation of number of changes made, but you probably would like to note that those changes were made in a field. So that's an enhancement that I'm working on taking care of. But that's how you'd use the L case function. Next, you have the ability to do multi-field replacements. Multi-field replacements are terrifying. These are replacements that happen over multiple fields and require you to take special care in terms of making sure that any data you capture, you put back. This also represents a slight change to the way the program used to work. When I added the multi-field checkbox, I made a change to the application that took away essentially a protection that used to be in the application to keep you from accidentally deleting a lot of data. That the program used to require you to take account of all of the new line fields. It does not any longer. You now can do multiple replacements without having to worry about those. So let me show you what that means. Let's say we wanted to move the data that is in this field here to the 052 subfield A and move that data into, let's say, the first 500 field after the subfield A. So we want to put it right here. Let's just say that for argument. I can use this replacement function and I can capture my data starting with equals 052, and I'm going to take the subfield A, and then I'm going to take all of the data from that subfield A that does not match an R or an N, so a new line or a carriage return, and I want to take all of that data. So that should take the 4050. Then I'm going to match everything, which is going to take the new line and out of that stuff, and I'm going to match down to the first 500 field, 100 field, and then I'm going to catch the subfield A, and I'm going to match again until I reach a new line or a carriage return. So this, in theory, should mean the first group has this data, the second group has, or the first group has this data, the second group has this data, the third group has all of the data to here, the fourth group will have this data to there. So that means I should put 4050 after that period, assuming all the data has been appropriately accounted for. So we'll do $1, which will take the first value. We will do we'll do $2, which will put the 4050 back into the record because we've matched them, so we have to put them back. Then we're going to put back the 300 field, so subfield 3, everything between the 052 down to the 500 field. Then we're going to put in the 500 field back, and then we are going to print in the subfield 2, which should represent this data here. And so if we click on use regular expressions and use multi-line evaluation and then run it, we get one replacement. And if we look at it, we see the 052 is still there. We didn't accidentally delete any data there, but this did not end up where it was supposed to. So I don't know what change I just made. Did I delete something? Let me look. I think I deleted data. So I'm not sure what actually happened, but it did not do what we wanted it to do. This is one of the problems of using the multi-line replacement. Is that, let's check and see what this looks like again, is that it is one of those that when it does tell you it did something, you have to be very particular to look and see what actually it did. And it could be that maybe I did not capture the data that I think I did. I might have captured, I don't know, maybe I captured a new line and I didn't capture the data that I wanted. Whatever it is, I didn't get it right. So as you can see, it's sometimes not easy to get it right in terms of pulling the data, but that's how the multi-line replacement function works. All right, let me catch back up with myself here. There we go. All right. Last one is the delete field function. The delete field function, I mentioned, lets you do different kinds of edits. The main reason for pointing this out is because one of the edits that folks tend to ask me about quite a bit are edits related to subjects. So I'm going to give you a derived subject example. A lot of times folks will ask me about how to remove fast headings. So I'm going to pretend like this is a fast heading. And so there are two ways you could go about doing this. One is you could target data that just has a fast, or if you're like some libraries, you may not want anything that's not an LCSH heading. So I may want to target data that's not LCSH. So in that case, I have two different strategies. The first one, if I am truly concerned about fast headings, I may just do something like this, 651, and the field data that I'm looking to delete is subfield 2 fast, and I can just delete that, and that's fine. I don't need a regular expression because that data there, the fast data in the subfield 2 gets identified, and I can remove it without having to use a regular expression. But let's say I'm a user that actually has no interest in non-LCSH terms in my record set. In that case, I have to do an indicator evaluation. So I'm going to evaluate the second indicator. And in that case, I do have to use a regular expression. So I check to use regular expressions. Remember, Marcedit gives you access to the full field. So 651 dot 3, because that's the two spaces plus the first indicator. And then I'm going to delete anything that does not match 0. So anything that doesn't have a second indicator of 0 should be deleted. Click delete field, and now two fields are removed. Appropriately, we see that the one with the 0 is kept, and the two that were second indicator 7 are removed. So the delete field function gives me access to delete either data in static data inside of a record set field, regular expression data within a field, or target data at a very precise location at the indicator level. All right, so how do I get help? It's a great question. So help is actually easy to get. The listserv is a great place to go and ask for help. You will find there's a number of folks on the listserv that probably can write these expressions better than I can, and use Marcedit to do very complicated work, regular expression replacement work, and have a clear idea of some of the quirks that come up periodically when working with regular expressions within that environment. You're certainly welcome to contact me directly through my email. Remember, my Gmail is the easiest way to get a hold of me. It's the one that I look at first. Or the listserv. I do encourage listserv because I'll see that as well. And if I don't see an answer, or if I know the answer right away, I'll answer it for you. And hopefully that helps other people. Also, I'll try to make things like this available. And I do periodically meander my way out and do workshops. But I think that hopefully things like this, the listserv, or the ability to contact people that are in your local area. There are a number of folks within the community that now do sessions, workshops, presentations on using Marcedit and editing their record data. That you'll be able to find either help locally for someone who can, if you need face-to-face help for more information on how to use regular expressions, or through the listserv, where we have just a tremendous community that's willing and able to provide feedback and suggestions going forward to help you on your way through. And if you are new to regular expressions and are working through the process and happen to find a resource that's particularly useful to you and would like to suggest it back to the rest of the community, let me know. One of the things that I've been working on over the course of the last, say, 2 or 3 months has been taking a number of pieces of information and moving it into that knowledge base. And I will fully admit I have to make it a little bit easier to find things in it. But one of the potential areas that I think could be beneficial from folks who are new to regular expressions or have gone through the process of learning and now have a set of resources that really help them work through that would be a knowledge base page that may be provided. New users or users that have been using the Marcedit for a long time but looking to learn more about regular expressions, a set of essentially resources that the community has, other members of the community have found useful. So if that's you, and you have resources that you would like to let me know about, I'd be happy to hear, so we could to create essentially a resource for folks who are struggling or just starting working with regular expressions, because I think once you start working with them and figuring them out, they actually become fairly straightforward, at least the vast majority and types of regular expressions you'll run. And then there'll be ones that are just pain that you kind of just have to learn, and like me, have to look up still all the time. So anyways, hopefully this has been useful. Again, I apologize for folks who had been looking forward to more of an interactive process. I was too, but unfortunately I just couldn't get the streaming to work. Maybe we'll take another crack at it sometime down the road once I've had a chance to take another look at the way that the service works and the type of resources that are necessary in order to both present, run examples, and get the streaming bitrate that I need. So anyways, if you have questions, let me know. Otherwise, I hope this was useful. And I will, in the description of the YouTube video, point to the slides, which will be on SlideShare for the resources that were in this presentation.